one says that which of the following types of waves cannot travel through a vacuum? You would remember I gave you two types of waves, which are mechanical and electromagnetic waves. Mechanical waves are the ones that require material medium for their propagation, while electromagnetic waves do not require material medium but they travel through vacuum. So example of electromagnetic waves that I gave you was Riemann-Roch, if you remember. So now Riemann-Roch is talking about radio wave, microwave, infrared wave, visible light, ultraviolet, X-ray and gamma ray. So you see that out of all of this one, the question is just asking that which of the following is a mechanical wave, and our answer will be sound waves. So the second question says that a string is sustaining a stationary wave when. The question is saying that when do we have a stationary wave? I also gave you two types of waves, stationary and progressive wave. A wave is said to be progressive when there is no restriction, while a wave is said to be stationary when there is restriction. So what I'm saying is that this is a progressive wave. So the wave travels out and it dies down. But in a stationary wave, the wave has restriction at both ends. So when the wave travels out, it strikes the surface, then it bounces back and it comes back. So a wave that moves in both directions will undergo what we call a stationary wave. So our answer is option C. Two equal waves. It's the same wave that went this way that is coming back. So two equal waves moving in opposite directions. That is a stationary wave. Next question says that if the wavelength of a wave traveling with a velocity of 360 meters per second is 60 meters, the period of the wave. So this question is trying to allow us to use the equation of wave that I gave you. On equation of wave, do you remember we said V is equal to F lambda. So now we're given the velocity. V is equal to 360 meters per second and the wavelength given is 60 meters. So we have to look for frequency, meaning that we have to actually look for period. So the first thing to look for is frequency, since period is equal to 1 over frequency. So frequency will be equal to V over lambda, and that will be 360 divided by 60. So 6 here 1, 6 here 6. So that means that will be 6 hertz. So the frequency is 6 hertz. So how do we get the period? Period is reciprocal of frequency, and that means that we're going to have 1 over 6, and that is 0.1666, which is approximately 0.17 seconds. So that is the period. So that's how to solve question 3. So let's move on to question 4. I hope you're learning. Take a pause and try to always solve these questions before you move on to the solution. So now question 4 says that for the wave motion represented in the graph below, so study the graph, the wavelength is given by, so what did we call wavelength? Distance between two successive points we called wavelength. Now this question is showing us two different points, S, P, Q, R and T. Now if you look at S that we have there, S is going from crest to crest, and that shows that S is a wavelength. P is not a wavelength because it's longer, it's not for a successive point. Q is half of a wavelength and T is not up to a wavelength. R is also like half of a wavelength. So from what we have there, only S is a wavelength, it represents a wavelength. So that's question 4. Question 5, I think this one is still talking about the terms that we talked about in class 2. A line, any line or section through an advancing wave in which all the particles are in the same phase is called. So I told you what a wavefront is. What is a wavelength? Distance between two successive points. What is amplitude? The maximum displacement from equilibrium position. The wavefront is the line on an advancing wave where two particles are said to be in phase, what we call the wavefront. So from what we are looking at here, wave speed is the distance covered in a given time, while wave profile is the graphical representation of the wave when it moves out. So now from what we have here, wavefront is our answer. The next question says that the following types of waves are all transverse, except, you would remember I told you what's the difference between transverse and longitudinal wave. So a wave is said to be transverse if the direction of vibration is perpendicular to the direction of motion of the wave, and a wave is said to be longitudinal if the direction of vibration and the direction of the wave are along the same direction. So that is what we call the longitudinal wave. So now in this question wants us to know all the examples of transverse wave except which one in this case. Water wave is transverse, Wave generated in a string is transverse, light wave is transverse, sound wave, you will remember in the class I showed you sound wave particles, how they move here and there. So that was in class 1, so you can refer back to the class. So the answer is D, sound wave, which is a longitudinal wave. Ripples on water is still talking about water wave. So by elimination, you already know option A is wrong. So looking at the next question, the wave motion shown below have a frequency of what? So you have to calculate the frequency. You are given a wave profile. Now from this wave profile, you can see there is a time of 0.4. So now, looking at the wave profile, for that 0.4 second, you have two waves. One, two, then the other half just complete it. Now at 0.4 you have two waves, and you remember we said that frequency is number of oscillation per unit time. So if I am to calculate frequency, how many waves do I have here? This is one, then two. So I have two waves in 0.4 second. So what would that give me? That would give me 5 hertz. 2 over 5. So that would give me 5 hertz. Now if I have 5 hertz, can I also solve it this way? You remember for one circle I have 0.2 second from here to here, and that is talking about period. So the time taken to complete one circle is 0.2 second. And what is frequency? Frequency is reciprocal of period, and that's going to be 1 over 0.2, and that is also going to be 5 hertz. So these are the two ways in which you can solve the questions. You can use the first formula, number of oscillation for a given time. I can use the second formula, 1 over t. From the graph, you can get your answer. So question 8 says that a radio wave has a velocity of 3 times 10 raised per 8 meter per second. So now, what's the velocity of the radio wave? Velocity is equal to 3 times 10 raised per 8 meter per second. And it sends out a broadcast on a frequency. So the frequency of the wave is 800 kilohertz. Now when you have kilohertz, you have to convert it to hertz. That's the frequency. So converting it to hertz, that will give us 800. Kilo means 10 raised per 3. So that will be times 10 raised per 3 hertz. So that's the frequency. The wavelength of the broadcast. So from our wave equation, V is equal to F lambda, then you can get the wavelength. So drop your answer in the comment section. Now, the wavelength of ultraviolet radiation is 400 nanometer. In this question, that's question 9, you have the wavelength to be 400 nanometer. And what's nano? You remember, nano is 10 raised per minus 9. So you can just convert that. That's 400 times 10 raised per minus 9. 400 times 10 raised per minus 9 meter. That is the wavelength. So now, we were also given the velocity. The velocity is 3 times 10 raised per 8 meter per second. Then you have to look for the frequency. Since you remember wave equation, I believe you should be able to solve this question as well, and leave the answer in the comment section below. So now, the next question is, so I think you should be able to solve this as well. The wave has a frequency of 2 hertz and a wavelength of 30 centimeter. The velocity of the wave is. So solve that question 8, 9, and 10. I'm going to bring back a set of questions for you to solve. I will tell you the day of your mock, and you will be solving those questions for me. So a boat at anchor is rocked by waves from crest. So there's a boat at an anchor, and this boat is rocked by water wave. And this water wave, the crest, they now said that wave whose crests are 100 meter apart. So the distance between two crests is wavelength. So if the crests are 100 meter apart, so let's say this is the wave now. There's a crest, So the distance between them is 100 meter. And what do you think that's talking about? That's the wavelength. Very good. So then you have the velocity to be 25 meter per second. At what interval? That means you're trying to calculate time. At what interval does this wave rock the boat? So that's what you're looking for. So solve that and leave the answer in the comment section. So I will let you know if you're right or wrong. So question 12. The diagram below shows two waveforms, X and Y. If the frequency of X is 30 hertz. Now, this question, I think we have the diagram like this. The diagram below shows two waveforms, X and Y. If the frequency of X is 30 hertz. Now, look at X and Y. The frequency of X is 30 hertz. So I can say F sub X is equal to 30 hertz. Then what is the frequency of Y? So I'm looking for F sub Y. Now, if you notice something here, the wave profile for the waveform for x and waveform for y, they arrived here at the same time. So that means it took them the same time to get to that point. And what does that mean? That means if frequency is equal to number of wave for a given time, that means the frequency of x is going to be the number of wave of x over the time for x, while the frequency of y is also going to be the number of wave for y over the time for y. So if I'm looking for the frequency of y, do I know the number of circles of y? Yes, that is, it goes like this. That's 1, 2 and a half. So that means that it is 2.5. But do I know the time? I don't. I can know the time from here. Now you remember, frequency of x is 30 and number of turn of x is just 1. So that's 1 over time of x. So that means that the time of x is going to be 1 over 30. And that 1 over 30 is also going to be, that should be 0.3333. Let me confirm that for my calculator. So I have 1 divided by 30. 1 divided by 30, that's, yes, 0 point, oh sorry, 0.0. So 1 divided by 30 is equal to 0.0333. So if time of x is equal to time of y, time x got here is the same time y got there. So that means I can look for the frequency of y. So that's going to be 2.5 divided by 0.0333. So 2.5 divided by 2.5 divided by 0. So 2.5 divided by 0.333 is going to give me 75 hertz. So the frequency of the wave is for which one? Y now is 75 hertz. While that of x is 30 hertz. Do you understand that part? So they got there at the same time. I know the number of circles of x. I know the number of circles of y. Then I want to look for the frequency of y. Since I know the frequency of x, I can look for the time that x got here. Since it is the same time x got there that y also got there, then I can use that time to calculate the frequency of y. And it's as simple as that. So that's question 12. So don't forget, solve all the related objective and theory questions from your past questions. So if you're writing WAEC, you are writing JAM, you are writing A level, pick your past questions and solve every question. If there's any question you can't solve, you can take a picture of it, you can leave it in the comment section. And if you find this video helpful, please subscribe, share with others, and let them be of benefit too. And the more you people subscribe, the more we want to do more, because we are here for you. And if you want these classes to be at regular interval, like maybe 2 3 days interval, maybe you have exams soon, please let us know in the comment section so that we can help you work on it. And don't forget to subscribe. So in the next class, I'll be talking about equation of progressive wave, and we are going to solve a lot of questions on that too. So stay tuned to the chapter on equation of progressive wave. That will be our class 4. So I'll see you in the next class. Thank you so